Okay, see Lindelof videos, ti-nspire CAS, solving on intervals. This is actually really easy. It especially comes up in trigonometric functions and in calculus, where either you want something on a specific interval or you have a function like a trig function where a value shows up over and over and over again. So just to give you a peek at what I'm talking about, it would look like this. So here we have this function f of x is equal to sine of 2x, and the question is, when is f of x equal to 0? On the interval 0 to pi. And you look and you're like, the function has a height of 0 here, 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 and periodically, cyclically, that value keeps reoccurring. So if you just go and ask the question of your calculator, you get back this horrible answer. So remember, we wanted our answer on 0 to 2 pi, and if you see the notation, it's intentional, and in this case, it's exclusive. That means not including 0, not including pi. So let's see what happens if we go to our calculator and we just ask the calculator the question. So we use our solve function, solve, and we say sine of 2x equals 0, comma x. So there's our solve function, and this should work perfect, except for the fact that, as we saw in this frame right here, the answer, there's all these possible solutions, and the calculator is saying to you, there's a way to figure out any of them, but you're going to have to plug it into this formula. So instead, what I wanted to do is this. I wanted to set this up as an interval and just say, okay, sine of 2x, and then check this out, such that, right, control this equal sign here, and then I'm going to use this such that key, such that 0 x, and if you look carefully, I'm being really careful to use the right form that they use. They wanted x is greater than 0 and x is less than pi. So all I'm going to do is this. I'm going to say control store, and I'm going to name this f of x. And now I have this interval established. I'm going to do the same thing I did on this top line right here, except a little bit different. So I'm going to do the same thing, solve function, and I'm going to say f of x equals 0, comma x. You have to have the correct form there. And there's our answer, right? And you can see this is so much better than this because you don't have to go through this crap here, this gyration of figuring out where you are. You could also set the function up a little bit differently. You could set it up, you could say, if our initial question asks us for x is 0 to pi inclusively, then you could ask the question this way, and I would do the same thing. I'd say sine of 2x, right? Control here, such that, and then I'm going to do 0, and then look, I'm going to do control equal sign. So x is greater than or equal to, x is less than or equal to pi. Right? Choose the pi symbol here. I think you can actually type in pi also as an alternate. It will translate it for you, but I know this way works perfectly. And then what I am going to do here is I'm going to save this as a separate function, if that's okay. I'm going to solve this, I guess, as g of x. And you see g is in bold right now. It's because I already have something saved as g of x. If I write something else and I name it g of x, it replaces it. So it's just going to replace it. And now look what happens. If I do the same thing, solve, and remember I named it g of x equals 0 in terms of x. Now it gives me all three of the possible solutions. And you can name whatever interval you want, and it will give you a whole lot of answers. But it is not possible for it to list out an exhaustive list here because the list is inexhaustible. So just by setting up an interval, you can do that. What else is a little bit cool that I'm only going to take the quickest second to show you is this. If I go to graphs, if I graph f of x, it even shows you that piece we're talking about. The problem is a little bit, I'm going to do this again, I'll put g of x, is that the calculator is not very good at distinguishing that in one of the functions 0 and pi are included, in the other one it's not. But it is interesting to see because it saves us from having to look at this whole thing, right? It just takes out the piece that you wanted to look at. And there are also ways to do this using the graphing function instead to actually find your solutions, going through the menu screen, but that's not what I wanted to show you. I wanted to show you how to save a function and include an interval. I wanted to show you how to save a function and include an interval that is inclusive of one value or both. And then I wanted to show you how to store that and solve it for specific values. This is going to be incredibly helpful in TRIG and in calculus, and in some other courses also. Somebody's going to write back to me and say, you could have just set up a piecewise function. There's a zillion ways to do this. I wanted to show you one that I thought was quick and relatively easy. So I hope this was helpful. If you haven't already subscribed, please do, and you know that your questions and comments are always welcome. Thanks, guys.